In this next section, we'll be looking at combinations, and combinations are a way to pick basically an unordered number of elements. So let's assume first that we have a set S. So this set here we'll call S, and it is comprised of n elements from which we want to pick only k elements. So there will be k elements within our event here. So the unordered sets that can be created, again, order not mattering, we call combinations, and that's written as the number of combinations from a set of n elements where we're selecting k elements. Another way of saying this, we are choosing k elements, and this is also really kind of the number of unordered R permutations of length k, but we choose to call these combinations. And you'll potentially recognize this right here, this n with a k under it, and this is called n choose k, which hopefully is ringing some bells for many of you. And n choose k, again, choosing k elements from a set of n elements, is the number of k element subsets of a given n element set. And jumping straight into the formula here, we say that n choose k is equal to n factorial divided by k factorial multiplied by n minus k factorial. So you'll notice that this is the same exact thing as what we had for our R permutations, but there's now a new multiplier down here in the dividend. And we aren't going to necessarily go through a proof for this, but if you're interested, there are a lot of great proofs that you can find out on YouTube if you want to either prove this to yourself or have someone else prove it for you. Now, if we do a quick sanity check of combinations, let's say that we have, again, just this formula, n choose k, where we have n factorial divided by k factorial multiplied by n minus k factorial. And let's say that we are going to try and find the extreme example where we have n elements and we're picking all n elements. So in this case, if we say that n is equal to the value 3, if we want to find n choose n, we would say that this is equal to 3 factorial divided by k in this case is n, so that would be also 3 factorial, and multiply that by n minus k factorial. Well, n is equal to 3 as is k, and so that would be 3 minus 3 or 0 factorial. Now, if we're trying to find the number of unordered ways that you can order the elements where there are the same number of elements as the sets that you're creating or the combinations that you're creating, there's really only one way to do that, and that's to put all of the elements in. So for this to work, we have to adopt a convention that is common in most areas of mathematics and will be the standard for the entire course, and that is that 0 factorial is equal to 1. And as long as we utilize that, then this right here becomes 3 factorial divided by 3 factorial and does in fact equal 1. Now, the other extreme will say that we have n elements in our set and we are choosing 0 elements of that set. And in this case, there should also be one option for that, and that is the empty set. So plugging this in to check out the math, we would say that we have n choose 0. So n, again, being 3 factorial over k is 0 factorial, which based on that decision we made earlier is just going to be equal to 1. And then we have n minus k, or 3 minus 0, which is 3 factorial. Again, this goes away because it is 1, and we're left with 3 factorial over 3 factorial, which is 1. And so again, we've kind of shown that there is an empty set as a possible combination and that this does hold up.